So, we want to talk about polar coordinates. Um, and so, this is just a different 2D system that we can use to describe the location of things. Or, I mean, polar coordinates can be used for quite a few things, but let's talk about the context of kind of location. So, we have our origin, right? Oops, let's change color. Let's go to black. Right, we've got an origin here, right? This is our 0, 0 point. And with polar coordinates, the two pieces of information that can tell you, let's just say we've got this maroon point right here. There's two pieces of information that can describe where this point is in polar coordinates. There's two things you need. The first thing that you need is a distance. Normally we call this r. Right? We need to know the distance from our origin. And the other thing you need to know is the angle. Usually this is our 90-degree point. So we'll just kind of draw this line out here. So we need to know our angle theta. So we know these 2 points. That will tell us where, or these two pieces of information that'll tell us where this point is. And so that means that theta, we could be in degrees or radians. It doesn't really matter, and you can just look up how to convert in between those two things. But theta could be 90, 180, 270, or it could go all the way to 360, which is the same as 0. Right, so that's just something to be aware of. But and r could be negative too, right? So here, we have this angle and a positive r, and you could have a negative r, and it could go back this way, but still that same angle. But that's a little unconventional, and you're probably not going to run into that as much, right? This is kind of what we want to deal with is positive r. Now, something that's pretty useful to do, especially if you want to plot these in Excel, is you can plot points in Excel that you're given polar coordinates, is to imagine this. Imagine that you've got a regular Cartesian coordinate system just with the same origin here. Right, so here's our positive y, and here's our positive x. And so in that case, you still just need two pieces of information to describe where that's at, right? You need this value, right, your x coordinate, and you also need this value. And so really, I mean, we can break this off into its own little thing here, right? It's just a triangle. Oops, it's not a very good triangle. Let's try that again here. There we go. It's a little bit better. So we got a triangle with an angle theta. We know the length of our hypotenuse, and so we're looking for y, and we're looking for x. And actually, you could work out the trig and figure out kind of what your standard formula is for that, but really it just comes out to be x equals r cosine of theta, and y comes out to be r, right, this is the times, r times sine of theta. And if you look at the trig, it's still going to work out to that. The thing to be aware of is, you need to know if whatever you're using to compute your cosine and sine, if you're using degrees or radians, right? So you need to, consider that when you're doing these conversions, and you might need to look up if you've got radians, how to convert that to degrees or vice versa.